For this video, we're going to be discussing the volume and surface area of prisms and cylinders. And specifically, we're going to be talking about rectangular prisms, triangular prisms, and cylinders. So first, we're going to discuss rectangular prisms. So, to find the volume of a rectangular prism, we're going to use the following formula. The length times the width times the height. Now, it doesn't really matter which one we pick to be the length, the width, and the height. We're going to get the same answer either way. So I'm going to say, in this case, we're going to say that the length is 15, the width is 20, and our height has to be 9 then. So to find the volume, all we have to do is multiply these three numbers together, and we get 2,700 centimeters. And for volume, our units are always cubed, because we're talking about 3 dimensions. So for surface area, we have this formula to work with. Now it's a little bit longer, but it's really pretty easy to do. It's 2 times the length times the width, plus 2 times the length times the height, plus 2 times the width times the height. What we're really doing is we're taking each of the faces of this shape, and we're finding the area of that, and then we're adding all our areas together. Because it's a rectangular prism, we know that there are 2 faces that have this area, 2 faces that have an area of this rectangle, and 2 faces that have the same area as this rectangle, for a total of 6 total faces. So to find our surface area, we're just going to do 2 times 15 times 20 plus 2 times 15 times 9 plus 2 times 9 times 20. Okay, 2 times 15 times 20 works out to 600. 2 times 15 times 9 works out to give us 270. And 2 times 9 times 20 works out to give us 360. Add all of those up, and we end up with 1,230 centimeters squared. For area, we're always going to be using square units. It's important when you're doing volume and surface area that you keep the difference. Cubed units for volume and square units for surface area. Always, always, always. So there we go. We found the volume and the surface area of a rectangular prism. So the next shape we're going to talk about are triangular prisms. And it's pretty similar to a rectangular prism, except our base is now a triangle instead of a rectangle. So our formula is B times H, where B stands for the base area. So we look at this and we say, well, the base is a triangle, so we should know that base area of a triangle, is 1/2 times the base of the triangle times the height of the triangle. So the height of a triangle is defined as the perpendicular distance from the base to the vertex opposite it. So in this case, our base of our triangle is 2, and the height of our triangle is 6. So if we're finding the volume, we're going to say V equals 1/2 times 2 times 6. So that's our big B, our base area. And then the height of our prism is simply the perpendicular distance between the 2 bases, which is 9. So we get 1/2 times 2 times 6 times 9. Well, 1/2 times 2 is 1, times 6 is 6, times 9 is 54. Our units are centimeters again, and it's centimeters cubed. So that's how we find the volume of a triangular prism. Take the volume, or take the area of the base, 1/2 times the base of the base times the height of the base, and multiply that by the height of the prism. So our surface area, to find the surface area, what we're going to do is we're going to take this formula here, HP plus 2B. Now the big B, same as up here, it's the base area. H is the height, and P stands for the perimeter of the base. So we end up, if we fill in our numbers, we end up getting something like this. H is 9. Then we're going to multiply that by the perimeter. Well, remember to find the perimeter, we just add up all the sides. So that's 7 plus 2 plus 2 times the base area. So that's 2 times 1/2 times 2 times 6. So if we work this out, 7 plus 7 plus 2, that works out to give us, well, 7 plus 7 is 14, plus 2 is 16. So over here we get 9 times 16. Over here, 2 times 1/2, well, those cancel each other out, so I get 2 times 6. 9 times 16 is 144. 2 times 6 is 12. 144 plus 12 is 156 centimeters squared, because we're talking about area. So there we go. We found the volume and the surface area of a triangular prism. So next up, we're going to be talking about cylinders. And we can think of a cylinder as being a circular prism. All right? It's a prism where our bases are both circles. So to find the volume, it's once again just the base area times the height. But because our base area is a circle, the area is pi r squared. So when we work this out, r stands for our radius, and h stands for height still. So when we work this out, we're going to say, well, we've got pi times our radius squared, so times 2 squared, times our height, which is 4. 2 squared is 4, so pi times 4 times 4. 4 times 4 is 16. So if we want to have an exact answer, our answer ends up being 16 pi centimeters cubed. Because pi is an irrational number, we don't want to actually do this multiplication. We just leave it like this to have an exact answer. Now you might sometimes see the approximate answer. So if I draw this little approximate symbol, this is approximately 50.27 centimeters cubed. Okay, so this is just the approximation of the answer. This is the answer exactly. So now to find the surface area, we use this formula right here. 2 times pi r squared. So that's 2 times the area of the base. So it's this base and then the circular base on the bottom, plus 2 pi r h. 2 pi r is the circumference, or the perimeter of the circle, and then h being the height of the shape. So we work this out. We get 2 times pi times 2 squared plus 2 times pi times 2 times 4. Okay, so if we do our multiplication, 2 squared is 4, times 2 is 8, so 8 pi over here. 2 times 2 is 4, times 4 is 16 pi over here. Add them together, 8 plus 16, we get 24 pi centimeters squared, because this is surface area question. Okay, or we can rewrite this as approximately 75.4 centimeters squared. All right, so now we found the volume and the surface area of a cylinder. Now, the most correct way to write these is the exact answer, 16 pi and 24 pi. On a test, you might see it as the approximate answer. In class, I want to see it as the exact answer. So finally, I want to talk about a word problem. So here's our word problem. A shipping container shaped like a cube is filled 2/3 of the way with packing peanuts. If one edge of the container is 4 feet long, how much space is left inside of the container. So the question like this, what we really need to figure out is what kind of shape are we talking here? And then we just need to apply the formula. So it says the container is shaped like a cube. Okay? So if you think a cube is simply a rectangular prism where all of the sides are the same length. So now we need to think, are we talking volume or surface area? Well, a good way to figure that out, if we read the question, if one edge of the container is 4 feet long, how much space is left inside of the container? That key word right there, inside, tells us everything we need to know. Inside always implies volume. So we think, what's our formula for volume? Well, volume of a rectangular prism is length times width times height. A cube simply being a rectangular prism where all the edges are the same length, we say, well, volume equals 4 times 4 times 4, or 4 cubed, which ends up being 64 centimeters cubed. Now that's the volume of the entire shape, but the question is saying it's filled 2/3 of the way, and we want to know how much space is left. Well, if we think we've got the whole thing minus 2/3 gives us 1/3 left. We know our volume is 64, so 1/3 times 64. We do that multiplication. Well, it doesn't work out to an integer. Our exact answer would be 64 over 3. I said centimeters. I should have said feet up here. Feet cubed, and this, once again, would be feet cubed. Okay, 64 over 3, or that is approximately 21.3 repeating feet cubed, right? Exact answer, approximate answer. So just to repeat how we did this problem, we looked up here, we found out what kind of shape we're talking about. It's a cube, which is a rectangular prism. We found the volume because we knew it would be volume because we were talking about the inside of the shape. And then, because we knew it was 2/3 of the way filled, what's left is 1/3, 1/3 times 64, 64 over 3, or 21.3 repeating feet cubed. So now you know how to find the volume and surface area of prisms and cubes, or prisms and cylinders.